Some of the goals behind doing this, I've already kind of talked about, but when they were developing the prototype and the idea behind the automated installer, primarily the same philosophy they took with ZFS was easy to set up. Make it easy so that people could go in instead of having to, create jumpstart services, then create profiles, then creating rules and doing all this, and then laying on top of that maybe some other type of layer to make it even easier. Let's just make it easy from the very get-go. They want it to be able to install from network or from local media. So this means either my images are sitting out on the network or they're sitting on a USB or a DVD that's inside the machine. But either way, I can do an automated install. Play fair with other OSs, and yes, I do mean the capability to be able to run it on top of Linux or even do Linux installs if possible. That's a future item. It's not going to be there today, so we can't go out there and grab the AI bits and be able to do Linux and Linux installs. But the idea is to make the framework there where we can play with other OSs. Support for all the different types of architecture, x86 and Spark. We go to a one-stop shop. I can do x86 and I can do Spark from one simple setup on one box and have the two different images and allow it to be able to determine whether it's x86 or Spark. Support for both LAN and WAN. WAN is coming, but LAN is there today. So have the capability of having a centralized install server and being able to do installs over the wide area network versus having to have multiple instances across each one of your different sites, especially if you have a site that may only have 10 machines. Be able to do that to the closest centralized server. Design philosophy, when they were coming up with this and writing down the design, is simplification, which seems to be a core. They want it to be simple. They want it to be much easier than what we use today. Decentralization, being able to have multiple install servers. So I can have, and you'll see when we start talking about the terminology, I can have services across multiple different servers rather than having to dedicate one server here or one server here for different types of servers. I can have clients be able to look out across multiple different places for whichever install they're going to get. Utilize standards. Don't use anything that goes outside what would normally be in somebody's environment today. What else? Yeah, use the same boot process of a live system. So they switched over to using a mini root instead of using some sort of boot archive.
Do all these changes require some supporting or corresponding changes in the Open Boot PROM?
No. There is a certain level of Open Boot PROM that you have to have. You have to have 4.17. Why is that? Because we make use of the WAN boot capabilities, which if you go prior to 4.17, doesn't have WAN boot capabilities. So I won't say it can't work. There are workarounds out there, but in order for it to work as designed, OBP has to be 4.17 or higher. For x86 machines, they have to be able to support Pixie Boot.
Okay.
Now, what about what's that Intel boot the Mac uses called? I can't remember.
EFI?
Is it EFI?
Yeah, the EFI label?
Yeah.
Well, I mean, you're talking about ZFS, so most of the disks that you're going to be using for ZFS root are going to be able to be EFI labeled. So EFI is just, the way we use it is just the label on the disk. But otherwise, it doesn't have any factor on this, on automated install. What was your question about that?
Well, the traditional BIOS boot blocks don't work. That's why I was curious if there was an EFI label.
Yeah, I mean,
It has boot code on it that would work.
almost all current Sun servers that are out there have disks that are able to accept the EFI label and be labeled as EFI. I think almost all newer servers from most other vendors do too. Maybe some of the older servers, I'm not sure about that. I'm not sure if that would have any play with it, because for ZFS usually you have to have a disk that's EFI labeled. I guess some terminology for those who are familiar with Jumpstart AI is basically synonymous with the Jumpstart. We talked about that, right? AI Manifest. We'll talk a little bit more about what manifests are, but it's equivalent to a Jumpstart profile. SC Manifest, Cisco ifconfig, and you can read the rest of these down here. For AI right now, at least in the current planning, AI is only really being planned for doing installs. Upgrades and updates will still be handled by BE admin and package. Another design part of this is it's going to be a client service model. So each one of the installation services that we have, and a service, when you're talking about AI, you define different services. Like there's an OS install service that you have. That's for installation. The clients are going to be able to go out and discover the services based on the service records found within DNS. So DNS is required. They can either do it through unicast or multicast type of a DNS. Default is to use multicast DNS versus unicast, but we do have the ability to configure it to use unicast DNS. Clients will query each one of the services to find out which ones match their criteria. So like I was saying before, I can have multiple different install servers, each one of them have different services. And the client will go out there and query and say, okay, here I'm looking for the service, and he'll get a list of about 5 servers or so that have this service. And they say, okay, well, this is your service, give us your criteria. The client then sends back over what his criteria are. This will be configuration information for, say, the client or something else like that. Then each one of those will determine which service matches the criteria and send it back over to the client. So the client say, there's no more having to configure on the client side. The client, it boots up, goes out DHCP, goes out, looks for the service that matches the criteria. We'll give back that criteria and we'll pick the service based on that. The client is more of a hands-off, no config. So the idea here is to go, if you're familiar with multicast DNS and some of the zero conf stuff that's going on within the standards, it's kind of geared towards that zero conf mentality. Kind of a graphical explanation of what happens within it. The AI is contained within this box. So your AI client is just out there, it's zero conf. You have basically web services, you have your mini root. You have the mini root in the user level archives are what will do the install. Then he'll go out and he'll look at the web server for the different services. Now you can have user specified manifest, AI system configuration manifest, and default manifest. The web server and the AI engine will actually determine which one of these manifests to use for each one of the clients. So you can think about this kind of like your rules, if you will, within